In this video, we'll be writing polynomial functions. In our first example, we want to write a polynomial function of the least degree that represents the graph. To write a polynomial function, we need to have factors and a leading coefficient. The factors we get from the zeros of the polynomial. So notice that we have 3 zeros at x equals -2, x equals -1, and x equals +1. Each of those zeros is going to give us a factor. Each of those factors also have a degree on it. To get the degree of the factor, we're going to look at the behavior of the graph at each of those zeros. Does it straight cross, wiggle cross, or kiss the x-axis? Looking at -2, we see that our graph straight crosses the x-axis. A straight cross tells us that we have a multiplicity of 1. At our next zero, -1, notice that the graph just kisses the x-axis. A kiss means that we have an even multiplicity. The directions said we wanted to write a polynomial function of the least degree, so we want the smallest even number, which would be 2. This zero has a multiplicity of 2. And then we have our third zero happening at +1. Again, the graph is just kissing the x-axis. That tells us we have an even multiplicity and we want the smallest even number, which would be 2. Okay, so we can start writing our function, p of x. Now, all polynomial functions have a leading coefficient. Right now, we don't know what that leading coefficient is, so we're just going to write a for the leading coefficient. And now we can put on the factors with the correct powers. Starting with our first zero of -2, the factor that goes with a zero of -2 is x plus 2. Remember, it's always the opposite sign. X plus 2, and this has a multiplicity of 1, so the factor gets an exponent of 1. Next, we have our zero of -1. The corresponding factor is going to be x plus 1, and it has a multiplicity of 2 on it. Then our third zero at +1, that gives us a factor of x minus 1, and it also has multiplicity 2. Great. Well, now we have to figure out what a is. To figure out what a is, you want to choose a point that's on your graph that is not an x-intercept, plug it in, and solve for a. Notice that we have the y-intercept. 0, 2. That's a point on our graph that is not an x-intercept, so we can use that to find a. We'll plug 0 in for x, 2 in for y, and we'll find a. So 2 equals a times 0 plus 2 times 0 plus 1 squared times 0 minus 1 squared. Cleaning up on our right side, this will be a times 2 times 1 squared times -1 squared. 2 equals a times 2 times 1 times 1. This gives us 2 equals 2a. Dividing both sides by 2, we get a to be 1. We're going to take this 1 and we're going to plug it into the polynomial function we wrote above. We'll plug that in for a, and that'll be our final answer. P of x equals positive 1 times x plus 2 times x plus 1 squared times x minus 1 squared. I always like to double check once I have my function just to make sure that the end behavior is supported. This polynomial function is 5th degree with a positive leading coefficient. The end behavior should be in from the bottom and out the top, and it is in our graph. That just makes me feel extra confident about my answer. Let's try another one. This time, instead of giving you a graph, I've just listed out some information. We want to find a quadratic function, we'll call it f of x, that has x-intercepts 2, 0, and 4, 0, and f of negative 1 equals negative 3. It says that it's going to be a quadratic function, so that tells us degree 2, total. The total degree is going to be equal to 2. It also lists what the x-intercepts are. Now, this is very similar to the previous example. See, in the previous example, we just looked with our eyes, identified the x-intercepts, and called them our zeros. Here, they've just listed it for us. So these are going to give us the factors. And it gives the zeros, and then from there, we'll get the factors. And then this last portion, f of negative 1 equals negative 3, that we're going to use to find the leading coefficient. This is simply an ordered pair, negative 1, negative 3. And we're going to use it just the way that we did in the previous example with the y-intercept. Since it did not state that any of the x-intercepts had multiplicity, we assume that the multiplicity is 1. So here we have our function f of x. We don't know our leading coefficient yet, so we're just going to call it a. We're going to use the x-intercepts to get the factors. Our first x-intercept is 2, 0. So that means that there's a 0 of 2. The factor that goes with a 0 of positive 2 is x minus 2. Our next x-intercept is 4, 0. So that's a 0 of 4, which gives us a factor of x minus 4. Notice that this would be degree 2, and since we're writing a quadratic function, we expect degree 2. The last thing we need to do is find our leading coefficient a, and we'll use the ordered pair that was given to do that. We'll plug negative 3 in for y and negative 1 in for x and solve for a. Negative 3 equals a times negative 1 minus 2 times negative 1 minus 4. Negative 3 equals a times negative 3 times negative 5. Negative 3 equals a times 15. We'd be better off writing that 15a. And then we'll divide both sides by 15. We get a to be negative 1/5. We're going to take this number that we just found for a, plug it into the function we wrote above, and that'll be our final answer. We get f of x to be equal to negative 1/5 times x minus 2 times x minus 4.